today, right, I have to say one thing. Happy UN World Water Day. United Nations has declared today as the World Water Day, not without any kind of this thing, so, right, census thing or something, but with a great kind of a stress on water. So all of you know that over 5,000 years, right, Indians, we have given prominence to one thing, that is water. So whenever we started our functions or whatever it is, we always remember, right, with great Dehimam. So please note that Jivanam Jivanadharam has been the Vedic saying, which has given the utmost importance to the water resources and the engineering of the water resources. It is not today, and without this particular aspect, right, there is no existence. This is what we have believed, and that is why it's the most important right discipline which will make us survive. So if you are, and all of us also know that 71% of the, right, the entire earth is covered with water, right, and of course here 96.5% is ocean, right, of the 100%, 96.5% is the ocean, and the 0.9% of which is, of course, the saline aspect is there, and 2.5% fresh water. We have very small amount of the fresh water available, and out of this, right, we have the fresh water 2.5%, we have got 30% groundwater. 30% groundwater. Why I am stressing this is, this year United Nations theme is groundwater, that is invisible to the visible. So please note that it is invisible, and so we, the engineers, the civil engineers, the water resource engineers, and environmental engineers, we make it visible, and it is possible for us to see this groundwater. So 30% of this 2.5% fresh water being groundwater, we have to really judiciously use. That is the United Nations theme for 2022. All of us will have to say that is today, that is 22nd March 2022, right? We are declaring this. And other 1.2% of the 2.5%, of course, right, is again the surface fresh water, and in the glaciers you have 68.7%. So this also means that we have less availability for the human use. That means we have to really, right, conserve water, recycle water, and use it in a very judicious manner. And this entire thing, right, is called optimization. So we have to optimize in every aspect of this, and including, right, the systems optimization. So that means, we once use water, correct, it becomes disused. And what do you do with the disused water? So that is called the wastewater. So please note that this kind of a disused water cannot be just, left like that. We have to make use of it back. So this is the process of recycling, which was not given importance, right? But during the recent times, right, it has become the order of the day. And we have always, right, heard that if you go to US, the New York City, they drink their own wastewater, right? Or in Tokyo City, they drink their own wastewater. But the same thing was done by Demat in Bengaluru, right? Hello? Am I audible, please? Am I audible, please?
No, in that word system.
Am I audible, please?
Ma'am.
Sir, you are audible, but somebody has unmuted there. So kindly others unmute the mic. Sorry, mute the mic.
Yeah. So today, right, I don't want to, bore all of you with what's artificial intelligence systems and other things, because I'm conducting one international conference on that in days to come with University Vishweshwaranjaniya College. Dr. Sivakumar is there, and Dr. N.Sivakumar is here, right? So I'll take their help, and of course we are doing it. And please note that what I am just touching upon is what are these three aspects of artificial intelligence systems? Why do we require it at all? And for what? For the water treatment plants and the optimization of the same. So this is the thing, right? And before I start, right, I would like to say one thing, right? Our Pujya Swami Nirmalananda Swamiji, right? He is a great civil engineer too, with a degree from IIT Madras, right? And a connection with Indian Institute of Science, and a great devotee of Swami Vivekananda, and right, and is a great believer of the Indian glory, and the right, and I give my salutation to Swami Nirmalananda Nath Swamiji, and also right Balagangadhar Nath Swamiji before I start this. Jai Gurudev. And as we understand this particular aspect, correct? So we have to say one thing, that what is this intelligence system and what is this artificial intelligence system? So please note that it is not a new word or something. So from 50s we have been hearing this artificial intelligence systems, correct? And for that there are various reasons, right? So we had right, and in 60s, right, it gathered more momentum with the fuzzy logic propounded by Dr. Zadeh, an Iranian electrical engineer, Dr. Zadeh, right, at the University of Southern California, and he started the Berkeley initiative. Right is a multidisciplinary approach. It's not interdisciplinary. There's a difference between interdisciplinary and multidisciplinary. So we do not want to reinvent the Newton's third law. Please note that one. It is not necessary. So here at the Information Science and Engineering Department, right, so you have your own faculty, and you need not just reinvent the Newton's laws or whatever it is. So you can appropriately take it and make use of it. So that is what. And I need not do anything, right, in computing or whatever the programming. So we have the cloud. We can import all these things, right, and do it away. So please note that the multidisciplinary approach is the order of the day from July 2022 in the new education policy. That means all our courses are going to be minimum 4 years, and after 4 years you will be directly going into PhD instead of the postgraduate level. So that is the new domain which is coming. So you start doing PhD. So directly you are going to get the PhD right after the degree, right? Even BSc is 4 years, BE is 4 years. So it will be a great challenge for all of us, right? More so, right, in the area of artificial intelligence systems. And I say this, our civil engineering students, right, may be feeling very scared or whatever it is. So happen to, but civil engineers need not be afraid, because all the applications of the artificial intelligence systems, right, will have to be coming to the mother, that is the civil engineering, because the applications are there only in civil engineering. Because why do you go for this artificial intelligence systems? Just to elevate the lifestyle and the living of the people, so living the standard of living of the people. So for this reason, so AI systems is not a taboo for the civil engineers. So in fact, advice like the new universities, like the Adi Chunchanagiri University, to just go ahead with the civil engineering department with new aspects of artificial intelligence systems and other aspects, included in it. So it's an inclusivity is important here, so that you are going to say, for example, I would say many of my students in civil engineering, they are doing MS in artificial intelligence in USA, like Arizona State University and all. I asked them, see, it's very important that we know both of them. We know civil engineering and we know this aspect, because the applications are there only in civil engineering to make the city smart, the smart cities. What do you mean by that? So unless you have a sound knowledge of civil engineering, you cannot be just this thing. So it is just like a some incompleteness, right? What we can call it. So there's no Purnatva in this. So to get the Purnatva, that is the multidisciplinary approach is very much required. That is the right Honorable Prime Minister Narendra Modi's right vision for 2022 July afterwards, correct? And it's like an octopus. So you will have to go right and have all the faculties. So with this, what we would say is, right, what is this intelligence system? What is the artificial intelligence system? Say we have the pronouns to the Chinmayananda, right, who always said that this, our system can be just included in this kind of a 9 kind of a factors. It is the body, mind, intellect, and perceiver, feeler, thinker, objects, emotions, thoughts. The BMT, BMI, PFT, OAT. BMI, PFT, OAT. Body is going to do what? It will perceive. What is it going to perceive? It's going to perceive the objects. And mind, what it's going to do? Mind is going to feel the emotions. And intellect is going to do what? So it's going to be thinking. So it's a thinker is required for the intellect. Intellect is to be in the thinker, and the thinker will think thoughts, right? So this aspect of the right analogy is going to be right to be modeled into a kind of a non-living system, That is,
Sir, your slide is not moving, sir. Your slides are not moving.
no, slide will move next. So here it's an introduction, sir. So BMI, PFT, OAT is going to be, no. First slide, please. First slide. Yeah. So I think the slide is moving, sir. And what I am just telling you is, right, the next slide. Yeah, artificial intelligence systems for water treatment plant optimization. So here I would like to say, what is artificial intelligence? What is natural intelligence, right? So without knowing what is natural intelligence, which is always superior to AI, let it be very clear. So let there be no confusion. So, right, we have to be, right, very much conversant with this. AI is required, but you cannot just give room for controlling the natural intelligence systems, correct? And ultimately, right, we are there, right, and we will be replaced, right, in our different branches like civil engineering, etc. But our jobs will be enriched by adopting the AI systems and other things. So we have more job opportunities, we can say, as civil engineers. So please note that all these things, right, we have got the problem of in the water and wastewater systems. We have a problem of the supply and demand, and also, right, availability, right? So here what is happening is there is a great amount of fuzziness and variation, which was, of course, first propounded by Zade, right, at the BISC, that is the Berkeley Initiative for Soft Computing, right, in the University of Southern California, where he had the hydraulic engineers, he had all the engineers, mechanical engineers, electronics engineers, and all the people. So, right, they came and sat together and made this, and they thought that there is no one discipline which can give the solutions, and therefore all of us should sit down and work on it. And Zade gave, right, instead of the term possibility, the plausibility. So he went on to define the fuzziness, and he gave the fuzzy set theory, for which Americans, right, American government banned it, right, of course, in 1968. Right, he was banned because he propounded a theory, that is the fuzzy algebra. Fuzzy algebra was propounded, and people could not properly, right, understand this. Until 1985, he had to suffer. And his student, of course, adopted this. He was a civil engineer, a structural engineer. So, of course, he used this domain, the fuzzy logic. The fuzzy logic was adopted by civil engineers. So, let it be very clear, right? There's no kind of computing engineer, etc. So, what I'm telling is our experience with IIT Kharagpur, where Dr. Sudhir Kumar Barai, the civil engineering department professor, right, and our friend used to take through these classes on fuzzy logic and other soft computing techniques to the computer science students of IIT Kharagpur. So you can imagine the civil engineering faculty throwing the subject to the computing sciences at IITs. So please note that therefore there is no demarcation. Some people say that this is a taboo for civil engineers and all, it's not good, right? Because it's the electrical engineers and the civil engineers who propounded this initially. And of course, they brought this to limelight in 1985. The Japanese waged a war, economic war on US, not the regular war, by using this fuzzy logic. And the fuzzy logic approach was, of course, taken in a way seriously by the Japanese, who just promulgated the fuzzy machines, and you see the comfortability conditions. There is no 120.5 degrees I will be comfortable, and so would be very comfortable at 25 degrees centigrade. It is not a correct approach. So we have to give a range, and the range aspect is very much important. So we have to for this range aspect. So from this degree centigrade to this degree centigrade, a human being could be just comfortable. So this kind of a comfortability condition was enunciated, and the theory of plausibility was brought about by Zade, and this was adapted by the Japanese in their fuzzy machines. And now it's very common to have a fuzzy air conditioner, and also the fuzzy washing machines and the other things, correct? And please note that these kind of aspects were introduced later into the curriculum also. That fuzzy logic was introduced, and then this is a soft computing technique to be incorporated into the artificial intelligence systems. And ultimately, what happened is that these fuzzy systems gained a lot of importance, and it was also adopted as an elective in our academic systems. And thereafter, of course, we had the neural networks. So that is mimicking the neural the network and our brain and the neurons. So that itself was taken as a model, and the ability of the computer or a robot controlled by a computer to do tasks that are usually done by humans, because they require the human intelligence and the discernment, And please note that you have to really model this brain as an organic thing to an inorganic kind of an entity. Yes, next. And we have the AI, the top-down approaches and the bottom-up approaches, which are more taught in the computer science and the AI and ML departments, which have to be a part of the curriculum in universities, the new universities, So in top-down approach, it seeks to replicate the intelligence. What I said, BMI, PFT, OAT, replicate that BMI, PFT, OAT by analyzing the cognition independent of the biological structure of the brain. In terms of the processing of the symbols, whence the symbolic label. So in the bottom-up approach is involving creating artificial neural networks in imitation of the brain structure, whence the connectionist label, could be given. So you have a lot of error analysis and all this will have to be done, and the artificial neural network was developed. So next, that is ANN. So we have also called, one more thing, that is suddenly mutations can occur. So for example, there is a lot of data, like over 100 years data. Our Dr. Ravikumar sir always used to say, we had to take at least data for the last 100 years, for the flood analysis and all, that is dam break analysis and all, So please note that when we do this, suddenly there could be a mutation. So suddenly there could be an improbable scientific development which could happen. That is due to the carbon footprint. That is carbon footprint is going to that is going to be global warming or the climate change. Today we are fighting this climate change, right? And this kind of a phenomenon, right, is going to be of a different nature, and this may not be right be possible for the either the fuzzy systems, fuzzy logic, or the artificial neural networks, right, to take care of. Then we have to talk about the totally changing the DNAs, right? That is the kind of aspect that the engineers should think about, and that is the genetic algorithm. So I have seen, right, my friends from California even working on plates and shells, design of plates and shells, and they have used genetic algorithm, GA. And when people laughed at it, so how civil engineers can use genetic algorithm? So please note that when they can do it for the structural analysis, why can't it be for the water treatment and the plant optimization? So this is a very important aspect of this. And why all these things? Because there's a huge diurnal variation and mutation. So please note that mimicking is like we can take the example of the honeybees, or we can take the examples of the ants, correct? And that is the ant colony optimization that our Dr. Jayakumar sir from NIT Warangal is an expert in that, NIT Warangal, and it's and mimicking and all these things. So we had to learn, right, mimicry of the entire ecosystem, and we had to bring in into the artificial system of the BMIP the OET system, correct? And then this would be, right, giving us a kind of solution. And this has been adopted, for example, where it is adopted, if you are asking me, please go to Thorakadnalli. Thorakadnalli, right, we have the water treatment plant, correct? So here we can say around 100 kilometers, say 120 kilometers, right, Thorakadnalli, right? So you get water from the KRS dam to the Shivsagar balancing reservoir and the Netkal balancing reservoir. And please note that it is bringing lot of clay and other turbidity into the thing, right? The balancing reservoir, which holds the water for the next 2 years for the city of Bengaluru, And you have a lot of challenges there. Which is beyond the human perception. So the human perception, right, we cannot handle this kind of an amount of water. So we require how much, right? All of you know that 2000 MLD of water is required, million liters per day of water is required, right, for the Bengaluru city, out of which 500 MLD is from groundwater. So this theme is groundwater, correct? MLD, 500 MLD is, right, the groundwater only. This I am telling on the lower side. It will be even more than this, 20% more than this. So my dear friends, what you should understand is this kind of a water that is stored in the balancing reservoir is totally not useful for direct consumption by the Bangaloreans. Then what do you do with this, right? And this every day it is changing. The quality is changing. And of course, the quantity is equalized now. Quantity is equalized, and thanks to the hydraulic engineers, they could do that. But what about the quality? The quality is totally changing, right, every day. And there is ingression which is happening, which is without our knowledge. The ingression is having, say, for example, some Kaveri paper mills is discharging wastewater into this, and the other things are happening. So that means a lot of pollutants are getting added here. So it is not that we are getting, 100% pure water H2O, and that pure water is not, right, good for drinking. If you drink the pure water, you will die. So the pure water is just H2O, which is having no mineralic content which is required for the people, right? So the human beings require certain amount of minerals and everything in a balance. So that is called optimization. So what the water treatment plant will do, it is going to optimize on this. So neither it is going to strip up the entire elements, right, with the various elements that are there, but it will bring it to a certain standard, specified by WHO, that is the World Health Organization. And the World Health Organization has given a chart, and all of you know this, right? I don't want to touch upon this. So it has got a chart which will, right, assign certain values, right, called the threshold limits. And these threshold limits, if it is exceeded, you have a problem with the human system. And particularly, say for example, the fluorides, correct, we have a terrible problem, right? And fortunately in surface water, you don't have this problem of fluorides. But today we are talking about groundwater, means then we have the fluorides. And recently, last month, you might have just seen, right, in the newspapers, like we got a very, very alarming message that invisibility of uranium in the eastern part of Karnataka, the entire eastern stretch of Karnataka, and also in Telangana, we have uranium in the groundwater. We did not know this. So it's only, right, a few months back, we, right, know it because of the Indian Institute of Science scientists, correct? And particularly near our college also, right, we have struck uranium, right, of 300 parts per billion in groundwater in Gotigere village, correct? So 300 parts per billion, whereas the international WHO standard is 30 parts per billion. So please note that who is supposed to do all these kinds of things. So you have to not only see the invisible, which is the order of the day for the civil engineers, but how do we do that? So all these things are humanly impossible, right, to do all these things. So then we should go for the artificial systems, artificial intelligence systems, which can, right, give these quantities and also the qualities, right? Sitting in a, right, college, we can just, right, collect all this data and then give the proper solutions. So using our natural intelligence. So natural intelligence cannot be discounted at any part because of the so many reasons, correct? Already you know that, right? If you are having cancer, right, nobody can prevent cancer. Nobody can prevent cancer unless, right, you go for right, a proper solution at the root of it, namely, right, containing the right aqua system from getting right in contact with radioactivity. We have this problem with the Himalayan region also, right? We are really afraid that there could have been, right, some radioactive kind of deposits, right? The Britishers would have left during the British time, correct? So it is still there, and if it is right, coming in contact with the water, right, it's going to be a great disaster. So please note that all these kind of thing comes under the water treatment plant optimization. So therefore, you got to collect the data efficiently and properly, which is not humanly possible. So that means we have to go for the right, acquiring of this data, etc., using the AI approach and the AI systems. And AI, of course, helps in extracting the meaningful insights from the data, from the invisibility to the visibility, and guides us in altering the behavior for effectively managing water. So track trends and reduce risk of water shortage. Yes, we can reduce the risk of the water shortage and identify the anomalies. So there's a diurnal variation, there is a annual variation, etc. So there's a variation when there is a, right, festival, right, etc. And the forecast demand and predict events and avoid the water loss, and particularly, right, we have seen willful loss of water is there in Bangalore. Nearly 40% of it in some areas, right, is wasted. If you just give right, 1000 ml, right, 40 right percent of it will be going as a willful waste. So everybody knows about that. It is right, the pipe is leaking, but nobody to just find out where it is leaking and what to do with that. So for that, AI systems are required nowadays. So we have systems which can identify the leaks, everything, and avoid the water loss and maintain the stable water supply, right? And normally a stable water supply for right? The civilized society is around 200 liters per capita per day. So 135 liter per capita per day is just a passing marks. And of course, the sewer management is one thing that we have to do, which is not being done. And of course, cutting the water usage is one thing that is left to the individual flats and other things. And of course, the water networks and the wastewater networks should work together. And thanks to the Bangalore citizens, we have the systems working with the help of the French company, that is the Demat of France, correct? So, and please note that we have the French connection in water. So in IASC also there is a department, right, of course, which is having the head of it is Dr. Mohan Kumar sir. And please note that it's the French facilitated department, France, has helped us. And Japan has also helped us. JICA is simply pumping money, without us taking a single interest, paisa of interest. So that's a Buddhist country. That is, Japan is a Buddhist country. So it's dedicated to JICA. JICA is giving. So you apply for JICA, you get the sanction, correct? We have worked on this, and in fact, one of the things. Detection of leakages, of course, is one aspect where gallons of water get lost every day, and a lot of work is being done, with the AI systems. So recently, a few days back, the Prime Minister of Japan was here, and he has identified a city, or the 7 cities, the Japanese cities. I'm very proud to say, then Birdi will be one of the Japanese city. It is declared a few days back by our Honorable Prime Minister Narendra Modi and also the Prime Minister of Japan. So they are jointly. So Birdi is going to have a tremendous kind of a growth because of the artificial intelligence systems evolving there, So we can say, we are also chip manufacturers, in shortly, correct? And with the Tatas also, coming in North Bangalore. We have great opportunities in, the water management, in homes and buildings also, not only for the cities. And of course, AI can monitor water usage by utilizing flow sensors. Flow sensors already adopted in Thorakarnalli, and BWSSP is using it. All of you know that, correct? And we can balance the flows and other things. And in fact, we have got the pulsator clarifiers where, we have got, the entire thing is managed by AI systems, artificial intelligence systems, the pulsator clarifiers, because we have to create a sludge blanket, and so that it can actually filter the water. It can filter the water. So that is the latest kind of techniques are coming, and that's only with the help of AI systems, because it is possible, humanly, it's not possible. Humanly, it is not possible because it's voluminous, correct, and is beyond the perception of the ordinary brain, though you are a very powerful entity. So the data cannot be handled. So the data has to be 100-year data at least, correct? And of course, we are taking the help of all the global companies, in this aspect, like the IBM, Demat, and other, kind of things. So AI and wastewater treatment plants, so you can just see, how we can incorporate in every aspect. Even only one person is able to maintain this particular wastewater treatment plant. You can just imagine, at a SCADA, sitting in a room, in an air-conditioned room, he can completely, handle the hydraulic systems. That is the largest WWTP in the region, built in 2005, that handles 63, megameter cube per year, plus or minus 1 million, people are using it, and 7 water treatment lanes are there, sludge processing lanes, etc. Please note that all these are possible in the, say, for example, this in Amsterdam West kind of thing. How these are possible is by one person. If it is possible, then how it is possible? That's due to the artificial intelligence systems incorporated into this kind of things, That means all the valves, where to open and how much of the flow should be there and what should be the amount of turbidity and all these things correct are to be there. Now we have got two standards. So all of us were not caring for turbidity in wastewater, that is treated wastewater. Now recently around say 1 year back, the central government, that is CPCB, Central Pollution Control Board, brought a new rule that the recycled water should have a 10-10 standard. Recycled water with a 10-10 standards means that 10 milligram per liter of BOD and 10 milligram per liter of TSS, that is the total suspended solids, right, will have to be there. And of course, turbidity will have to be less than 5 NTU, that is nephelometric turbidity units. And if this is going to be right, the possibility, how do we do about it? So please note that this is only possible by the artificial intelligence systems, right, which will give us the quality. And only if it is 10-10 standards, we can recycle this. Right, earlier we never cared for wastewater systems turbidity. Then we used to laugh at it as during our student days. But today, the student is talking about the nephelometric turbidity units for wastewater, that is the treated wastewater. So this is the thing, and of course there are various toolings available like this, right, and AI systems, right, and of course this will be a matter of the multidisciplinary aspect. So many things are there, and Alibaba is there, Azure is there, the Microsoft, everything, right, are there, right, which are going to help us. And in neural network, of course, right, we have this kind of linear activations and the bias and the average output value, tuning, less, and of course, right, all these things are there, which is not only a property of the AI and ML branch by itself. AI and ML is not a branch by itself, let me tell you. So it has to import the values right from the civil mechanical systems. Unless the civil mechanical systems exist, right, so AI and ML cannot exist. Because what is the application? End application is to help the entire the humanity. To help the humanity, what you have to do? You should know, right? And if you know, you have to study civil engineering, my dear friends. And the model performance, why? Say for example, pressure, the airflow, energy consumption, etc. See how fuzzy it is, right? It is the variation that is handled by civil engineers is impossible to just understand by the mind itself. So please note that this could be a PhD topic, right? And all of you can do, I think, 1,000 PhDs with this kind of thing, right? And of course, the approach is very, very different here. The required airflows, the blowers, the valves, and all are under control, not of the human being, but by the machines. So to see this, we can go to Rishabhavati treatment plant. And you can go to Degramont, you can take special permission and go to the SCADA room and you can see all these things. And also you can go to the thing where Koramangala Chalgata Valley near the old airport road, or the Hebbal Valley, the Hebbal treatment plants. So 3 major treatment plants for the thing. Or if you are in Delhi, you can go to the Vokla treatment facility near CRRI or Jamia Millia Islamia, it is there, correct? So please note that it is the French colony near that. And we had a problem where a lot of jaundice, occurred suddenly in Delhi in 70s, right? And why did it happen? Please note that it is bad civil engineering. So please note that it is suddenly, people realized that the treatment plant was, getting water from the Yamuna River, correct? And the Yamuna River itself, on the upstream side was having ingression due to the domestic wastewater, not even industrial, domestic wastewater. Please note that what will happen if the domestic wastewater is coming, because then there is a possibility of virus coming into the river, and whatever you want to remove, yes, everything will be removed, but not the virus. It is the contagium vivum fluidum, correct? There, in Australia, we have even found that is the DNA, the virus, right? Virus DNA, right? Right? Our right COVID virus, correct? We have found it, correct? If please note that if the virus can come in contact with water, nobody can help. The humanity will be totally destroyed. So you want that kind of situation to be existing? Please note that it is not humanly possible for just human beings to right tackle and optimize on these treatment plants and other things. But you have to go for the AI approach using all the techniques I told, namely the fuzzy logic. You have to study and ANN, you have to study civil engineers, I'm telling, and mechanical engineers, you have to study, and then genetic algorithm, you have to study, then the ant colony optimization, you have to study, then you have to study the mimicking and all these things. You have to incorporate all the computing discipline into the civil engineering. So once you bring all these things, then AI and ML enabled civil engineering, if you just declare, I think that will be the first branch to be opted by all the people. And you will not have 60 people, but you can have 600 people. So please note that why things are not thought of in this direction is a very sad thing, that our people cannot understand this kind of thing. So how to change the syllabus, right? How to just reincorporate things, how to make inclusivity, all these things, right? We have to make up the syllabus change. I think great people are here, Dr. Ramprakash sir and all this, Dr. Vikumar sir is here, and so all of you, right, will give a serious thought, sir, for this, especially, right, this kind of an optimization using the artificial route, sir, right? So this, of course, is going to be a forward-looking approach, and of course, keeping on talking will be a futile exercise. So you have to make it learn. So particularly the hydraulic and water resources engineers, right, are making things learn, right? So because it's a machine doesn't know, right? And please note that you have to make it learn at least 100 years data, not 1000 year data, at least 100 years data. Then it can give a dendritic analysis and other things. So this is a very important thing, that simply, taking a thing and doing modeling is of no use. You have to take the data which is available for the last 100 years or even more than that. So this is what the learning. So you have to make it learn, and then also error analysis. So these are things which have to be incorporated into the civil engineering curriculum, right? I thank you very much for giving me this opportunity